Chapter 2, Biochemistry. This is the nature of matter. This starts on page 34. I'm Mr. Hollins, I'm your teacher, and we're going to learn about the nature of matter, starting with atoms. And we see that atoms start with a nucleus, and in the nucleus it is a cluster of protons and neutrons. So we have two of these particles, protons, which are positive, and neutrons, which are neutral. Additionally, then we have electrons in orbit around the nucleus. So little electrons follow these paths that we will call orbits. So the orbits are followed by these electrons, and protons and neutrons in the nucleus, and electrons in orbit. Protons and neutrons in the nucleus, and electrons in orbit, in one of or many of these orbits. Fine, now page 35 shows us elements and isotopes. So first of all, read that section, and for elements, write yourself a definition. What are we going to put for elements? The next thing they tell you about are, here it is, isotopes. Give yourself a good definition for isotopes. Write these in notes that will be handy that you can find at any time. And then page 35 finishes with radioactive isotopes. So here are three vocabulary words. That's page 85, and they give you a little chart there for the differences with numbers of neutrons and protons. Next, on page 36, we see chemical compounds. And a compound is a substance formed by the chemical combination of two or more elements in a specific proportion. The physical and chemical properties of a compound are usually very different from those of the elements from which it is formed. For example, hydrogen and oxygen, which are gases at room temperature, can combine explosively and form liquid water. Sodium is a silver-colored metal that is soft enough to cut with a knife. It reacts explosively with water. While chlorine is very reactive too. It's a poisonous greenish gas that was used in battles during World War I. Sodium chloride, table salt, is a white solid that dissolves easily in water. And as you know, sodium chloride is not poisonous. In fact, it's essential for the survival of most living things. Looking further on the page, we see where it says chemical bonds. What are the main types of chemical bonds? Here we have ionic and covalent. So in talking about chemical bonds, we want you to remember atomic structure. We have protons, electrons, and neutrons, and then we have the hydrogen atom, which is just one proton with an electron circling there. Additionally, we'd like to say that hydrogen, it's probably a proton surrounded by an electron cloud. So the electron's moving so fast that there's really not one spot where we can see it, but it just exists in a cloud around that nucleus. Additionally, a helium atom would have two protons and two neutrons, and thus two electrons in orbit around that nucleus. That's a helium atom, and that's simple structure. We talked about the isotopes. And so hydrogen is a positively charged hydrogen ion. It's just one proton. And then we have the hydrogen atom, which is a proton with an electron going around it. Next, we have a negatively charged hydrogen ion, which would be a hydrogen atom with an extra electron, and that's where it gets the additional negative charge. Then we have two things here. Hydrogen, which is a regular hydrogen atom, and then a deuterium or isotope of hydrogen, and that would be a proton and a neutron with that atom, and then, of course, the electron in orbit around it. That's an isotope. Different number of neutrons than protons. An ion is different number of electrons than protons. So comparatively, we're always comparing the elemental number of protons with the other particles in the atom. So when we talk about chemical bonds, we want to talk about the ionic bond. And here's a diagram of a sodium and a chlorine atom. And so what happens is in an ionic bond, electrons get transferred. So we see a transfer of the electron from the sodium atom to the chlorine atom. So now we have one less negative particle for the sodium atom and one more negative particle for the chlorine atom. Transfer of electrons, that's ionic. For a covalent bond, what we have are shared electrons. So now two atoms get close enough and the electrons, or the shared electrons in the middle, they can orbit either nuclei, the one on the right or the one on the left. And so they're shared electrons. This is a covalent bond when we share electrons. Ionic is transferring electrons. Covalent is sharing electrons. Did I say that right? Ionic is transferring electrons, and covalent is sharing electrons. A covalent bond is sharing electrons. Sharing electrons. And then we see the ionic bond. This is transferring electrons. So when you see test questions, you want to look for these key features, either sharing electrons or transferring electrons, and that will give you an idea of which is which.